Thank you so much. So thank you everyone for being here today. My name is Peiman Hosseini. I'm the Director of Engineering Operation at Metamaterial. And today I'll present to you two products that Metamaterial is developing that are specifically targeting the safety and the performance of lithium-ion batteries. So very briefly about Meta, we are a company that was founded in 2011. We have been part of the NASDAQ since 2021. And really the company works on designing and manufacturing nanostructured material and devices that can improve safety, performance, connectivity of various different applications. So today I'll present to you some of our battery or energy work, but I encourage you to go on our website and take a look at our whole portfolio of offerings. So thankfully, I don't have to explain to this audience why lithium-ion batteries are important, how much they're growing, how much the market is growing, how many technology they enabled. You guys know all of that, so I can just skip this one. Maybe one thing that you're not so sort of aware of it is the safety implication of lithium-ion batteries. So we know that batteries can catch fire, and I don't want to do any scaremongering. This is a very, very rare event. So we're talking, one failure every, tens of millions of batteries. However, when those happens, the consequences can be catastrophic, not just for loss of life, obviously injury to the people and the users, but also to the very company that are using this battery. Not even necessarily manufacturing them, they're just using them. So here are three sort of very, very famous example. This is the Samsung Note debacle when they had to recall the product twice. Everybody knows about this. I think my dad knows about this. And the company probably lost 5 to 17 billion pounds between profits and reputation and so on. Most people will also know about the Boeing and the problem they had with their own onboard devices powered by lithium-ion batteries. And every now and then we read about a Tesla who just randomly catch fire and it was parked somewhere for a random reason. So what I'm trying to say here is that yes, these events are rare, but they can have massive consequences for the companies who basically use these products. And if you look at actually why they happen, so why does a battery catch fire? The failure modes are many, and the statistics are a bit sort of weak. So it's kind of hard to tell exactly why a battery fails most of the time. But I guess you can kind of group them into three different sort of situations. One is when there is some sort of internal circuit, sort of short circuit that's maybe driven by a manufacturing defect. Maybe there is a dendrite, something that's basically is connecting the anode and cathode electrode together. These start to draw energy uncontrollably inside the cell, and eventually the cell catches fire. It might be because of overcharging or general misuse of the battery, maybe a problem with the BMS, something like that. And also, obviously, something that has to do with mechanical damage, so an external agent, maybe an accident, maybe a nail penetrating the cell, something from the outside that basically damages the cell, leading to a fire. And so these are kind of common effects, but as I said, it's difficult to exactly pinpoint and to say, okay, mostly it's an internal problem, let's work on that. Mostly it's outside, let's work on that. It's very difficult. So what the approach that we took is let's take one step back and just analyze what happens. Okay, not so much why it happens, but what happens. And you can sort of divide a thermal runaway event or a battery catching fire into three separate phases. So phase one is when the battery has the anode and the cathode to find a leak path somewhere internally within the battery that starts drawing current. Okay, that can be, as I said before, maybe the separator has been punctured by dendrite. Maybe there is a defect in the manufacturing. Something happens, and there is current that uncontrollably goes from one electrode to the other. And if that's not stopped, if that's allowed to continue, then obviously that will generate heat. The heat will start accumulating, and that goes into a second phase that basically involves the separator, where it will start to shrink, start to melt, and more contact between the electrodes will basically happen, which means more energy and currents will be drawn, which means more defects are going to be created, et cetera, into an exponential runaway effect that essentially leads to combustion. Okay, so this is what happens literally, and obviously there is other things going on like there's gas release, the fire might propagate, et cetera, but this is sort of the main 3 points. And also, I wanted to give you a little bit of an idea about how bad a fire involving an EV is. So we know fires are bad. I think we all agree on that. But how bad is a fire that involves, for example, an EV? Sorry, and that's actually pretty bad. So we are talking about